All right, so let's look at what linear programming looks like with real-life situations. You have 140 tomatoes and 13 onions left over from your garden. You want to use these to make jars of salsa and jars of tomato sauce to sell at a farm stand. A jar of tomato sauce requires 10 tomatoes and an onion. A jar of salsa requires 5 tomatoes and 1/4 of an onion. You will make a profit of $2 on every jar of sauce sold and a profit of $1.50 on every jar of salsa sold. The owner of the farm wants at least 3 times as many jars of sauce as jars of salsa. How many jars of each should you make? Okay, so let's talk about this. The first step, as in any word problem, is to define your variables. And again, we always find that in the last sentence. How many jars of each should you make? To maximize profit, we'll deal with in a minute. So we're going to say capital T is the number of jars of tomato sauce. And we'll say L is the number of jars of salsa. Okay. Now, in linear programming, the first thing we need to find is the objective function or objective quantity. You can call it either way. We'll call it the OQ. So I'm looking now for the OQ. And I see that I want to maximize profit. That's my object. Okay, my objective is to maximize profit. You'll see minimize cost. You'll see all kinds of things. Right now I want to maximize profit. So first I need to find out what profit is. So I'm going to go back into the word problem and see where they talk about profit. And you can see this sentence right here. You will make a profit of $2 on every jar of sauce and $1.50 on every jar of salsa. So I'm going to make $2 on every jar of tomato sauce and $1.50 on every jar of salsa. So there's my objective quantity. And again, same as in system word problems, once I use numbers, I'm not going to use them again. Okay, the next thing I'm looking for are my constraints. Okay, so my constraints. And in yesterday's work, this was all given to you, but it's not given to you today. Constraints are things that you're held to. What am I held to? Well, I'm held to the number of tomatoes. I only have 140, so I can't make a recipe that requires 150. So what are my requirements? Well, one is the tomatoes. I have to be less than or equal to 140 tomatoes, and that's right here. And if I look into the word problem, I see a jar of tomato sauce requires 10 tomatoes. So I need 10 tomatoes. And a jar of salsa requires 5 tomatoes. So that's going to have to be less than 140. All right. Well, what about my onions? I am held to 13 onions. And if I look into my word problem again, the tomato sauce only uses 1 onion, and the jar of salsa uses 1/4 onion. All right, so I've used everything except this last sentence here. And let's see. Okay, the owner wants at least 3 times as many jars of sauce as jars of salsa. So he wants more sauce than salsa. So my tomato sauce has got to be at least, so greater than or equal to 3 times the salsa. Okay, so think about this. Here's my tomatoes. Here's my salsa. Okay, this tomato side is 3 times bigger than the salsa side. So to make this equal, I'm going to multiply this side by 3. So that's why tomatoes has to be at least, that's greater than or equal to, 3 times salsa. Okay, now I know I have to make positive numbers, but we're going to hold off on those constraints until we see what the graph looks like. So I've transferred over the constraints. I've solved them for y, so I think you can follow that the blue line solved for y is here. I've put solve for y, meaning solve for t, so I've put the jars of tomato sauce on my y-axis, the jars of salsa. I'm going to pause and graph the blue line. Okay, there's the blue line, beginning point at 14. Each of these tick marks is 1. Okay, so, and a slope of -1/2. I'm now going to pause and do the purple line. Okay, so there's the purple line. It had a y-intercept of 13 and a slope of -1/4. I'm sorry about the crappy lines. It's very hard to do straight lines on such a small graph. I'm now going to pause and do the yellow line. Okay, so there is the yellow line, and I want it to be greater than the yellow line, so if I put my pen on the y-intercept, I want to be greater, which means I want to be on this side of the yellow line. So now I find my intersections, my corners, but before I do that, you can see that I have bound my region here, here, but I don't have it bound here. This yellow and purple and everything and blue could all continue out here. So I have to put that my jars of tomato sauce is greater than or equal to 0. So I'm going to add that one. I don't have to put in a bound here because I end at this corner. So now I've put myself into this triangle. And I have a 0 here at 0, 13. I have a 0 here at 0, 0. And I have a 0 right here. Now, it's where all three intersect, actually, I think. But what I'm going to do is I'm going to solve the yellow and the blue. I'm going to solve a system between the yellow and the blue. So if you're not sure of an intersection, you can't guess. All right? If I had been on better graph paper, I'm 95% sure this is 412, but I'm going to solve the system. So I'm going to use substitution, and I'm going to take this 3L and I'm going to substitute it into that T. And what I get is 10, 3L, plus 5L is less than or equal to, because I'm solving it, 40. This is 35L is less than or equal to 140. If I divide that, sorry, these really should say equal, because I'm solving where they are equal, where they are touching in one point. This should equal 4. And I'm just going to be, yep, so that's 4. So this point is L is 4, which is my x. And if I put 4 into here, that means T is going to be 3 times 4, so T is going to be 12. So those are my 3 intersection points. Okay, now that I have my 3 corners, and remember my ordered pairs are L, T, X, Y. X is L, salsa, T is my jars of tomato sauce. I now will plug in my corners to my profit. And if I plug 0 in for L and 13 in for T, okay, so I've got to be careful with that. So I'm going to do 2 plug in the T plus 1.5 plug in the L. This is going to be $26. And if I plug in 0 for both, this is going to be $0, obviously. And if I plug in, remember this 4 is my L, which is going to go in here. So I'm actually plugging 12 into T plus 1.5 times 4. I'm going to get 24, 25, 26. No, I'm going to get 30. So this is the point that gives me maximum profit. So I will make 4 jars of salsa and 12 jars of tomato sauce. To maximize profit. Okay, guys, have a great day.